This is homework 9.3, proving triangles similar. Determine whether the triangles are similar. So like number one, we know that these are vertical angles or congruent. We know that this line and this line are parallel. So alternate interior angles are congruent. So we know that triangle AEB is similar to triangle DEA. And what's the reason? It's going to be angle-angle similarity theorem. For number two, we have two triangles. We want to check if they're similar, but the only information we have is angle and congruence. So we definitely know that it won't be side, side, side. We know that it won't be side, angle, side, because the side would have to be proportionals. Of course, one says it would have to be proportionals or ratios. So we can't do that. We only have one angle, so we can't prove the triangle is similar. So we're going to say not similar. And the reason is because we don't have enough information. Number three, we do have two triangles and one. We know that this side is parallel to this side. We know that this angle is congruent to this angle. We know that this angle is congruent to this angle. And because of AA similarity, we know that they're going to be similar. So what you need to do is make a statement. Triangle MLN is similar to triangle, and let me erase this because I didn't get to see this. So it's going to be PO. Number four, we have two triangles. We have this side that is congruent to this side, but we don't have any measurements. We have this angle is congruent to this angle, and that's the only information we have, so we would say it's not similar. For number five, we have two triangles here, and we do have the included angle is 90 degrees, and they're both congruent. So now we have to make the ratio 10:5 as 28:14. 10 divided by 5 is 2. 28 divided by 14 is 2. And because we have sides, the side have the same ratios, they're proportional, it's going to be similar because of side angle, side similarity. So we need to write a statement. Triangle TVU is similar to triangle UXW. For number six, we have two triangles, and we know they're isosceles. The two triangles are isosceles. 26 is congruent. Segment MN is congruent to ML because they're both 26. OQ is congruent to PQ because they're both 13. And if I did the ratios, we have 26 is to 13, 26 is to 13, and we have 30 is to 15. And we know that the scale factor is 2. So these two triangles are similar because of side, side, side. So we have triangle NML is similar to triangle OQP. A 1.4 meter tall child is standing next to a flagpole. So we have a child here, and we have a flagpole, and we know the child is casts a shadow of 1.2 meters. At the same time, the shadow of the flagpole is 7.5 meters. We know that the child is 1.4 meters tall, and of course we have similar triangles, and we want to know how tall the flagpole is. So we're going to say 1.4 is to x as 1.2 is to 7.5. So what you're going to do is you're going to multiply 1.4 times 7.5, 1.4 times 7.5, which is 10.5, and then you have 1.2x, and then what you need to divide is by 1.2, and I did that on the side, so we know the flagpole height is 8.75 meters. So number 9, we have two triangles. We know that these are vertical angles, and we know that these are alternate interior angles. And I do know that these two triangles are similar. So triangle ABE is similar to triangle DCE. And I can set up the proportion. So we have 14 is to 18 as 3x is to 4x minus 1. And then what we're going to do is we're going to cross multiply. So we have 18 times 3, which is 54. And then we have 14 times 4, which is 56. X minus 14. So we're going to multiply 14 times 4x and 14 times negative 1. So this is going to be 54x equals 56x minus 14. Subtract 56 from 54. So we have negative 2x equals negative 14. Divide by negative 2. So x is equal to 7. So for the answer, x is equal to 7. The two triangles are similar because of angle, angle. A stick 2 meters long is placed vertically at point B. The top of the stick is in line with the top of the tree from point A, which is 3 meters from the stick, and is 30 meters from the tree. How tall is a tree? So we have the ratio 2 is to the height of the tree. We'll say that's x. And then we have 3 is to the distance, the total distance of the triangle. So it's 30. So 3 is to 30, right? The total distance. So we have 3 times x is 3x. 2 times 30 is 60. Divided by 3. So x equals 20. So the height of the tree is 20. Thales, an ancient philosopher, familiar with similar triangles. One story about him says that he found the height of a pyramid by measuring its shadow with his own shadow at the time. So you can see here the two triangles, and they are similar. So we know that the height of the pyramid is unknown. We know the distance from B to C is 318. And we know that the height of the person was 5 feet tall, so it's 5. And its shadow was 6. So you're going to cross multiply. So we have 6 times h is 6h is equal to the product of 318 and 5. So it's 1,590 divided by 6. And that's going to give us the height of the, so the height of the pyramid was 265